So hi everyone, really glad to see you here today. So my name is Justyna Janczyszyn. I'm a software engineer at 10Clouds. I'm mainly concerned with backend and RESTful APIs, but I'm also very passionate about DevOps, and this is something I'd like to talk to you about today. So, more or less what's my presentation plan? I'd like to give you a couple of reasons why you might want to consider using AWS at all. Then I'm gonna tell you a little bit about some of the most important services and how would you or could you use them. Then I'm gonna tell you a little bit about some practices that I found very useful, and also about a couple of tools that I think are really cool and you might like them. And at the end, I'm gonna do a practical demonstration with the use of most of the services I'm gonna talk about, and probably that is gonna be the biggest part. Okay, so why would we consider AWS at all? Well, some time ago, it was just fine to have physical servers on premises, like to have our own data centers and stuff like that. But to be honest, the upfront cost is really high, and when you have to scale or you have to invest a lot of money upfront before you can create your products, with the era of the cloud, you basically pay for what you need at a particular moment. So basically, just like that, you can have as many servers as you want, and you pay for them based on the usage. Well, AWS is also very flexible. It offers a very diverse range of services. So it's not only infrastructure, so for example, virtual servers, but also you can have platform as a service, like for example Heroku, and many others. Also, the security concerns are quite good. AWS is the biggest cloud provider. It's being used by a lot of companies, and there you have a lot of different layers of security where you can make sure that whatever you deliver is going to be protected from the outside world. And well, for beginners as well, there's a free tier, which is really nice because basically for the first year, you can use a range of services for free. This includes actually, this includes EC2 services, which is basically Amazon's ways of calling virtual servers. And basically for a year, you can use an instance, one instance for free each month. And as well as Amazon S3, which is basically like unlimited FTP server, you could call it like that. So there you can upload all your data that you are serving to your clients, for example. And yeah, you don't have to worry about availability of the data. Amazon takes care of everything for you. There's also RDS, so the relational database services, which is basically, we could call it the Amazon's SQL solutions. So there you have the most used ones. So for example, like Postgres and MySQL. You also have Aurora and some others. There's also Amazon Lambda, which has become very popular lately. So there's this notion of function as a service. So basically, what it means is that you don't have to worry about the underlying infrastructure at all. You basically deliver some code, and AWS provisions everything for you. You can connect it in various ways. You don't have to use it on its own. Like, you can integrate it into your system. So for example, you could connect different parts like EC2 and RDS as well. There's also an elastic load balancing balancer included in the free tier, which is kind of nice because basically the range of services that are included there will let you demo the most basic stuff that you would need to try out if later you decided to build your infrastructure on it. So basically you could have a load balancer. Behind it you could have a couple of virtual servers, so EC2, and you could connect it all to a relational database and store your objects on S3. So basically you have all the infrastructural parts are there for free for the first year, of course up to a size of the instances and stuff like that. There's also CloudFront, which I think is really cool for serving static websites, or basically the front end to your backend as well. It's actually all of them, but the elastic load balancing are going to be showed in the demo, so I'm going to talk about them later on. So right now, maybe a little bit about best practices. So with AWS, some things are maybe a little bit weird, like for example, when you create an account, right now it's actually still connected to your Amazon account for buying stuff, and like that's the root account, and you should actually never in practice use it later. So basically it's a very good idea to create a separate user account, not to use the root one, and there is also a good idea to add some multi-factor authentication so that you don't have to worry that it's gonna go to somebody who might want to, I don't know, cause you some trouble and generate costs for you. And yeah, also as far as long as we're talking about costs, it's also a good idea to create some billing alarms, which basically means that using CloudWatch, you can automatically provision some alarms that, for example, you're gonna receive emails or text messages telling you that you exceeded a certain threshold. So, for example, you might realize that it's only been the first week of the month and like you're already paying more than you wanted to pay. So probably something is wrong. Maybe you forgot to destroy some of your infrastructure that you're not using anymore. Also, another thing about AWS is that it has a variety of regions all around the world. And what that means also is, so it's not only about the latency, so that like you can provision your infrastructure as close to your clients as possible, but it's also about costs. So some regions are more expensive than some others. Sometimes it even happens that some regions are faster than the others. Another thing to consider is that not all the services are available in all the regions. So before you start setting up your infrastructure, you might look into, are all the services I need available in those regions? Because when you need to connect services and infrastructure pieces inside your system, you want them to be mostly in the same regions, unless you're deploying your application across a range of regions. Another good thing is to use the AWS client, because obviously you have a nice console interface, like the web interface, where you can basically click on everything and set up your infrastructure there. But very soon it becomes really annoying to click everything a lot of times. So basically with AWS client, you are able to have some scripts that are gonna do most of the stuff for you. Some other stuff is, so as we go into scripts, try to automate as much as you can, because very often what happens is that you build one piece of infrastructure, but then you find out that actually you need more pieces of the same, for example, service, or you want to have more servers doing the same thing, or for example, you might want to have different environments like development environment, staging environment, production. Also, if you have multiple projects, then you can abstract some of the knowledge and reuse them in all the infrastructure pieces, like for example, networking or like security groups and concerns with permissions and stuff like that. Actually, there's going to be a lot about automation in the demo, so we're going to get back to it. And okay, so this is maybe not so obvious. I'm also going to show it in the demo. There are various ways of authenticating with Amazon Web Services, AWS. So basically, if you have a user, you can create keys with which you can access your resources, for example, via the AWS client. Also, this goes that if you provide such a key to your instances, they also can interact with other infrastructure pieces. But very often, it's actually a better idea not to use raw keys, but instead of keys using a role, because a role is so basically there's this different schema of authentication where you don't actually need to pass anything, but using a role, for example, in your instance, the instance is going to ping an endpoint inside AWS, and based on that, it's going to be granted access or not. So this is especially nice because you don't have to manage your keys, and you're not afraid that you might that they might go to somebody that they're not supposed to go to. And also another thing is that basically you can also set it up very easily using automation. So the automation service for AWS is CloudFormation, which I'm going to discuss in a moment. Okay. Some of the interesting stuff at AWS that you should probably look into. There is a very nice tool for exploring your how are your costs going and what are you spending the most money on. So basically, either you can have you can create different reports based on, for example, the usage of different services. Another thing is that if you tag your resources, so for example, you have a project, and there you could tag all your resources. So for example, your virtual servers, your RDS instances, and so on with tags. Later on, you are able to filter by those tags. So for example, let's imagine that you have a lot of different clients and each of them has their own infrastructure. This might be actually very nice to be able to generate different reports for them based on the resources that they are actually using. Also, another thing is that when you are creating your resources, for example, if you're using automation tools like such as CloudFormation, you can actually see before creating the resources how much you're going to pay for them. So basically, there's this tool that lets you plan your infrastructure costs, and there basically before spinning everything up, you can check it. Okay. Another nice thing is so basically you have the basic AWS client, but also AWS's team has delivered this extended AWS Shell, which I think is very nice because you have a lot of resources and a lot of commands that you would have to memorize. So it's really hard to kind of remember, was it like describe, was it like list? And here you can actually see it. So wait, maybe I'm gonna show you. Oh, or not? Okay. Okay. So for example, here we are inside the shell, and let's see, for example, what we can do with our EC2 thing. So here we have nice auto completion, and so this is much easier to use than simply having to type everything. Yeah. So for example, here we can or we cannot. Yeah, live demos. Yeah. Anyways, check it out if you have not already. Okay. Okay, so I think it's enough of theory. Let's see something real. So, going back to here. Is it big enough? Can you see? Okay. So what do we have here? Okay. So basically, this is a very, very simple Django application. Also, there's another part connected to CloudFormation, where we defined our infrastructure using templates. So first, I'm gonna tell you about CloudFormation and show you how the templates look like. There's the repo link in the presentation, so you can go check it out later. Okay, so basically, what I really like about CloudFormation is that there's this declarative style of defining your infrastructure. Also, like, no matter how many times you're gonna execute it, the state of the infrastructure is gonna be the same for the given stack. And so this is not only nice because you don't have to perform the tasks manually. It's all being done automatically by the machines, which is very fast and also like not as error prone as doing it manually. The other thing is that also you can keep it in version source control, so that not only do you have the history of how your infrastructure evolved, but also you share the knowledge across the team, and also like there's place for pull reviews. So you know the bus factor is not as low as sometimes with just one person taking care of the infrastructure. Okay, so maybe let's see something. Okay, still it's the format of it is quite complicated. CloudFormation supports both YAML and JSON. This is written in YAML. I think YAML is much nicer because A, you can have comments, and B, you don't have all the extra stuff that doesn't really bring much. So what do we have here? In the templates, we can have parameters that are later on going to be passed to creation of resources. So basically, you can create templates that you can use across multiple stacks. So it's reusable. And also here we have, so this is our main stack that is creating all the other stacks. So as you can see here, for example, we have a stack for virtual servers. So here we defined how our instances should look like. So basically everything is defined here. So for example, like what type of the instance is going to be, what volumes it's going to have, where to mount them, in which region it should be, which Amazon machine image it should be based on. And also, like, here you can assign tags to your resources. So as I told you before, you can use those later, for filtering your resources if you, for example, want to list them in AWS client, or, for example, for generating cost reports, and many, many others. Here, together with our virtual instance, we also create elastic address IP and an instance profile. So this is this role that I told you before about. So this is actually very useful in the case of this particular, or actually probably a lot of applications. But for example, so here in this Django application, I'm uploading some images directly to S3. Okay, no, I said that wrong. So basically, there's an API which provides the front end with signed URLs to which the front end can upload data directly, so that we don't bother our backend with storing, and so that we don't have to upload the images first to the backend and then to S3. So we do it directly through the client. And what we define here is basically policies enabling our instances to sign those URLs that will be later used by the front end. So in such a stack, there are a couple of sections. So we have the parameters, so our variables. We have our resources. So here we have all the resources types. So for example, here we create an instance. Here we create elastic IP, the instance profile, so role, some policies, and we also can have outputs, which also can be exported in other stacks to interconnect them together. So for example, in one stack, we can create some resources that are going to be later used in another stack, so we can have dependencies on one another. Okay, so here we are also creating security groups. And we also are creating the security groups for our RDS instances, so our databases. And here we are creating the database instance. And so basically those were particular stacks for some resources, and here we created all together. In a moment, I'm going to show you how it looks like in the console, on the front end. So maybe it will be more clear. Okay, maybe I'm just going to do that. And one other thing, the parameters can be either passed on the command line, or they can be passed using a JSON file. So basically, for example, when I create new infrastructure for a new project, the only thing I need to change are the parameters. So basically, I would have multiple parameter files for different projects, and I would reuse the same CloudFormations templates and stack. Okay, so. Okay. Some other reasons why I also think that CloudFormation is really nice. A is because we have the management of all our resources in one place. So here we can not only see what our resources are in the given stack. To make it smaller, I think. Okay, so as you can see here, we have our main stack, and this stack creates all the other stacks that are dependent on one another. And here we can list all the resources that have been created for it. Okay. Yeah, so that later, when we do it manually, we might, for example, forget that, oh, I created this S3 buckets, and then I created this database, and then I added something else. Here we have everything in one place, which is nice. Also, another thing is that when we, for example, are done with a project, we can simply destroy all the resources from one place. You might ask, oh, but you could do that by mistake. Yeah, I could. I have. But another thing is that you can actually add some policies that will prevent you from destroying, for example, databases, so that when you delete them, like there's going to be a warning and it's not going to let you do that. Or, for example, that it's going to leave the database intact even after all the resources are destroyed. And another thing is also here you have outputs. So, for example, and you can also query the outputs via the AWS console. In this demo, I actually used Ansible. But so in Ansible, I need to pass some variables to later for my Django application and to set up some other stuff. So basically what you could do is using those outputs, you can create variables for your Django application, for example. And anyways, like you have it all in one place, so you don't have to look for it or keep like a separate documentation because it's all here. Another thing is that when you create all those resources, because here there are a lot of resources, and for example, oh, you might have an error in your template or something's wrong. A, there's a validation, but B, if something still goes wrong, there's a rollback. So basically you don't risk having some of your resources and not all of them. Basically, it's either all goes well or we do it once again. Okay. So okay, so this is basically our backend stack. So here we have a virtual server, we have a database server, we have Elastic IP, and also we here created a subdomain for our application. So basically all the infrastructure that we needed. Oh, we also have S3 buckets for storing our media. And so maybe just let me show you the management of domains and subdomains, because I also think it's really nice here. Okay, so also in Route 53, which is the service for DNS management, you can buy a domain or you can import a domain that you bought somewhere else, and you can manage it really easily. Okay. Okay. I'm just going to show you that we created subdomains for our demo project here, and it's connected. Oh, this is actually another part. This is for the front end, but we also have the part for the back end, and it's connected to the Elastic IP that we created also using CloudFormation. So as I'm saying, like basically everything, all the policies, all the connections between services have been created automatically. Oh, and maybe another interesting thing is, I'm maybe gonna show you in the command line how it's being done. So basically it's, So it's a command like this. We're basically calling AWS CloudFormation create stack. We give the stack a name. We provide the template body. We provide in which region we want our infrastructure to be created, and we pass a parameters file. And there's this flag that's needed for any resources that have to do with identity access management. Also, another thing, because our stack is very complicated and has many parts, before doing that, I uploaded to S3. So that later the other stacks can refer to it inside. Also, but you don't. If you don't like command line, you can also do it using the web interface. And it looks more or less something like this. So basically, so the first step would be to create a stack. And here you provide the URL of the S3 object that you have previously uploaded. And then you can define all your variables here. And oh, I don't remember that. So anyways, like we could create another stack right now. Let me maybe just fill this one, and then I'm going to show you also the cost planning. Oh, so here you get the link to the cost estimator. Unfortunately, it does not always work for all the regions, but we can check it out. Yeah, and unfortunately, it did not work right now, but I'm just going to show you that here you have all the resources, and here you can basically, yeah, it should happen automatically, but it didn't for some reason. Anyways, you could also manually input what services you need, and then you can create your estimate and also export it and share it with other people. Okay. Okay, so this is basically the same stack as the one that I have created before. It takes a while, and well, maybe hopefully until the end of the talk it will be done. Also, another cool thing, so this is only the stack for the backend. We also have a stack for the front end. Unfortunately, I had to create it in another region because it turned out that, so one thing, AWS also provides you with free SSL certificates that you can use in CloudFront and also in Elastic Load Balancer, which is pretty cool. So like you cannot use them in EC2 instances because there you have to upload the certificates manually. But since we are using CloudFront for our front end, together with S3 and Route 53. We also use this free certificate to allow us to have HTTPS. Okay. Okay, so I think that's enough about the infrastructure. Maybe I'm going to show you the application right now. It's really, really simple. Basically, what it does is yeah, so basically I just wanted to show you how so the only thing that the backend does is create a signed URL that later the frontend, being searched from S3, is using to upload files directly to S3. And also, oh, I forgot, we also have a Lambda function that is actually notifying the backend that a certain object has been uploaded. So I'm just going to show you how it looks, and then I'm going to show you the code. So we have some nice dog picture. We upload it. Okay. And okay, I know it doesn't look impressive, but what happens underneath is that so the frontend uploaded the image directly to S3, which in turn triggered a Lambda function, which in turn notified the backend that an image has been uploaded. And then the frontend asked the backend through an API for all the uploaded images. Why I think it is cool? Because basically you don't stress your backend with keeping the media and like uploading it first to the backend and then to the to S3. Okay. Okay. With the Lambda functions, so Lambda supports Node, supports Python, unfortunately only Python 2.7. So this is our Lambda code. What happens here, I'm also going to show you in a second like how it looks like in the web interface. So what happens here is Lambda is being triggered by a put to our S3 bucket. And then for each record, well, basically with each upload, just one record. But anyways, we ping our backend and we set the URL for the image that has been previously updated, because previously we only created the object so that we could create the ID that is later being used. So basically, this is how Lambda looks like in the AWS console. It also supports some environment variables. Actually, this has not been created by CloudFormation, but we could actually even add Lambda function creations to CloudFormation. So basically, then we could have everything being set up with just one command. And also, like, since we have variables, you know, the same Lambda functions might be used for more than one application. Yeah, basically that's it. And here, so here's the configuration. one thing that I don't really like about Lambda is that basically it only has a very limited amount of external libraries, so basically only the libraries for Amazon Web Services. So for example, here we used requests, so we had to create a bundle and upload it to Lambda so that it had the library that we needed. So we uploaded it with a zip together, and then we added a trigger. So basically, this is our S3 bucket to which the front end is uploading the files directly. And well, I'm gonna go somewhere. Nope. Sorry. Yeah, so basically whenever an object is being put to this bucket, this Lambda function is being triggered. Yeah. Okay. Okay, I didn't finish this slide. There are two cool sites. One is Amazon Web Services in Play English. I'm gonna show you. So basically here you have a list of probably mostly all the services, and there are like some funny phrases like how the author thinks that they should have been called in the first place, and a very short description how or what would you use that service for, and also like there's a line or two about some other services that might be similar to this service in AWS. And the other blog post, or actually that's a blog. So if you're interested in AWS and automation as well, CloudNote is a really, really cool blog that I advise you to check out. Okay, that's basically it.